Hello everyone, in this session today you will get to know the real benefits of NetDevOps and continuous integration and delivery, and how a build server can automatically deploy and test the proposed configurations in testing, staging and production environments. Our goal will be to create a complete environment that demonstrates the benefits across our entire network infrastructure. So without further ado, hello. I'm Stuart. I'm a Senior Developer Advocate here at Cisco DevNet. Cisco DevNet is a developer relations team at Cisco. I'm also an author for Cisco Press, a main contributor and DevNet expert for the DevNet Expert program and exam. We're going to start here today by looking at our network. Network has always been a very manual process. Built mostly by the command line and interfaces which were mainly built for human consumption and readability. However, this method has led to many inconsistencies across our network with errors and even outages. Which is why myself, this presenter, can confirm has happened many times to him during his career. In fact, networks have been more and more complex with an increased operational cost and dependencies over the years. So any simplification that we can bring to the network has been gladly welcomed. And one of those things that we do within networks now is decoupling the software and hardware. By decoupling the software and hardware, this implies the advantages of having two independent lifecycle managements, one for the software and one for the hardware. And while dealing with two lifecycle managements adds a little more complexity as traditional vendors assembled the software disaggregation, this gives us the flexibility to pick the best of breeds. In certain cases, that flexibility does outweigh the complexity of the solution itself. We see that engineering teams need to be both agile and adaptable. The only constant in the networking industry is the change. So can engineering teams adapt to this? Interestingly, pretty much all network engineers' job descriptions these days require some sort of scripting skills such as Ansible, Python or Go. And while scripting can take a lot of the laborious repetitive tasks, they still have their shortfalls, as they are often snowflake scripts owned by one person and often run locally. Therefore, moving up from just network automations to a DevOps model is important, as DevOps advocates automation and monitoring at all the steps for the software construction, from integration and testing to release to deployment and infrastructure management itself. But before we start this transformation journey, we must train the automation. Training the automation about a network is like onboarding a new team person. You wouldn't let a new person with no knowledge of your customers and business goals loose on your network. A new network team person has to go through training, as does all of your automation processes for the network. Many networks use a combination of different features, and the term usually refers to network protocols such as BGP, OSPF and interfaces. By using infrastructure as code, a feature could be represented by a Python object with attributes which represent that feature or the configuration on the device itself. So by implementing a learning method, we can provide a representation of the current operational state of our devices per feature. Our training learns the operational state by executing a series of commands and passing that output into a common data structure across different operation systems. With infrastructure as code, we can restore these as key value pair structures across all of our network devices. And we can store the output, which makes it possible to take a snapshot of the network state at different positions in time and then compare it to different states as well. But how do we store all of this? As mentioned before, when automation has been used on the network, it has often been built and ran and owned by just one person. This leads to a complete lack of control of this automation. Using source control in a network for storing device configurations will help teams enforce a healthy process and workflow. All the changes can be stored in source control before being pushed into a production network, this giving anyone a linear history of changes or with a log of individuals responsible for each set of changes, and enables companies to enforce things like reviews, having somebody else review your changes before they get put into production, and having automated tests performed against the files in the source control system. Furthermore, most source controls can also add metadata about the change, such as why the change was made, or reference back to an issue or trouble ticket for a customer. This additional metadata proves very useful in troubleshooting monumental issues or perhaps even outages. By using automated tools there, we can get a great reduction in the number of issues by leveraging low code and playbooks powered by these workflows. And with the efficiency of closed-loop intent-based operations, common network issues can easily be resolved spontaneously. This makes networks a lot more resilient, as we are now removing the need for manual interruption in case of events, which means that we can offer a higher standard of delivery and service with even greater consistency. Our teams that have done this have seen an increase in strategic workforce by automating a lot of repetitive tasks, which many were subject to human error, helping drive our business improvements and also innovation. Finally, by using automated tools, you can also get greater insights into network control, making teams more responsive to change through analytics. The more visibility a network has and understanding of precisely what's happening in networks at given points of time will give the ability for control and be able to adapt as needed, such as increasing capacity or even bandwidth. A lot of network success relies on telemetry, automation, machine learning, and programming with declarative intent. By doing this, you can accomplish the following by building production networks and building CI/CD network that can lead to a good in-network behavior, delivery of predictable analysis, and recommendations and remediations. It can also help placement and operate autonomously with active monitoring and reporting providing to our customers, our organizations. This will ensure network performance behavior remains aligned to our business goals. All of this will help build an autonomous network which is predictive, adaptive, and more agile to its environment. So now let me show you how this can all be placed. We'll move now into a demo, and for this demo I'm going to use NSO to show you how all of this is powered. If you're not familiar with NSO or Network Service Orchestration, NSO is an orchestration platform for hybrid networks that can provide lifecycle automation. NSO is a model-driven platform as well for automating all of network orchestrations. It provides multi-vendor networks through a variety of network element devices or NEDs. In our demo today, we will show us how we can track the status of the network configuration at any given point in time, and who proposed and approved those changes for specific configuration changes. It will also provide us with visibility on what the differences are with continuous integration at different points in time versus a previous situation, and how we can also define and run required tests and passing criteria before accepting these changes as successful. So let's look at our workflow just to begin with. This is our production workflow from beginning to end, and as you can see there are a number of steps here. This is our entire CI/CD pipeline as it runs today, starting with adding a new task, having the task reviewed, and automating the testing of all of those tasks as well. So let's look at some of these steps a little bit closer and unpack what all of this means at individual stages within our workflow. Within our workflow, we have Ansible playbooks, as you can see from the snippets of code that I'm sharing. The playbooks are pulling in information from the network automation and orchestration tool NSO. This takes the configuration from the network devices in a JSON format and then transforms this into YAML. This allows engineering to both add, remove, and make changes. The main point here is that we don't need to write YAML from scratch because the int.vars.yaml file creates the YAML structure itself. All we need to do is copy and paste the part that we want to change and then merge this back into the device. This is possible as the official NSO Ansible module uses the JSON RPC API. This allows for fancy commit options and a lot more nerd knobs, if you will. The downside is that some of the engineers are not really familiar with JSON RPC as we've found, but are more familiar with REST and are more comfortable troubleshooting REST or RESTconf. And by development, in my experience, it could be easier using the REST-conf modules if you are looking to put these kind of changes in. Once the changes are made, we can push this back into our CI/CD pipeline and then into the network orchestration automation tool. So let's look at how that works next. So here we are changing device configuration. And in this example, this shows a snapshot of a Cisco router which was passed using NSO and then converted to YAML. The core router has one IP address for an interface. The IP address for the interface has been updated and changed from 37 to 73. When this change has been made, our version control system can now kick off and run the pipeline. This is where it's really crucial. Here we can actually see what that pipeline looks like. In the version control system here, our automated checks check the highlights, and you can see here that another engineer can review the changes. What we can see is that GitLab itself has used line-based diffs, so it will internally always store the complete changed lines. And we do not need to see, all we see is the last octet of the interface IP, or as the diff or the change. If the change looks good, this is where our automated testing can now be performed within our pipeline. Our GitLab CE uses a YAML file or GitLab CI YAML for our project configuration, and we place the file in the root of our pipelines for our project pipelines jobs and for all of the environments. Our YAML file defines this set of jobs with constraints of when they can be run. In this case, we're using PyATS to do the tests. PyATS, however, is an automated test system written in Python and will connect to the network devices and run the required tests in the jobs that were made to change the interface IP addresses. It then will send a sequence of ping tests to check to see if the device is reachable to perform the testing itself, as we can see within the script itself. Next is our automated checks. Once these checks have been ran, we can see a visualization of this, which shows the sequence of the tasks, and the tasks here is to check the connectivity. However, we can see from this message that this impact actually broke connectivity. It was unreachable. The terminal output is stored below. This allows us to review the change and pass changes in metadata format to address the impact of any change to the services, allowing our team to look further into potential issues here. As this change failed, we would automatically not push this into production network, as none of the tests actually passed. It is only once our tests passed that the changes will get pushed into our production network, and we will see this as a successful change. This is how our entire pipeline goes from making changes to testing to pushing this into a complete pipeline into production. I hope you've enjoyed this presentation today. This brings us to a close of how we've implemented a CI/CD pipeline to validate and perform testing across our entire network infrastructure, really allowing that DevOps methodology and GitOps lifecycle into our complete production environment. If you have any questions, please reach out to me. My email is on the left-hand side. You can find me on Twitter as Big Evil Beard, and you can check out my code repositories on GitHub, where a lot of these things I've spoken about today are linked in my GitHub repository. All of the content as well for a hands-on lab can be found at developer.cisco.com, and feel free to follow us on Twitter as well, and also check us out on GitHub, where there's even more code examples around CI/CD pipelines for software integration and also network infrastructure using many platforms. It's been great speaking with you today. I hope you've enjoyed this presentation. Thank you very much.